Now let's look at the 6.4 power and power factor. The average power, also known as the real power. There are no power dissipate in the capacitor and inductor. Capacitor and inductor absorb power on the first quarter and return to the AC generator on the next quarter cycle. The only power dissipation takes place is in the resistor. The average power dissipated in the RC, RL or RCL series circuit. From average power equals to IVR equals to I square R, and from the Faso diagram, we can note that the average power equals to IRMS, VRMS cos phase angle, which is V is equals to IZ. And from the average power, I square Z cos phase angle equals to PR, and PR is the average real power. Therefore, the power factor is defined as cos phase angle equals to PR over I square Z equals to PR over PA, where PA is the apparent power equals to I square Z equals to IV. From the Faso diagram, power factor can also be calculated by using the equation below. Cos phase angle equals to R over Z. And the instantaneous power is defined as the product of the instantaneous current I and voltage, which is P equals to IV. For the pure resistor, P equals I naught V naught sine omega T square. Pure capacitor, P equals to half I naught V naught sine 2 omega T, and pure inductor is P equals to half I naught V naught sine 2 omega T. Now let's try example number 9. Here is the information given. We need to find the power factor of the circuit and the power factor of the circuit at the resonance. So the impedance is equals to 141.4. The power factor of the circuit is equals to 0.707, and the power factor at resonance is cos phi equals to R over Z equals to R over R, which is equals to 1. Now let's try question number 10. Sketch the graph of instantaneous power P of the pure inductor against time t. Explain on the significance of the variation of the power against the time. Here is the graph of P against T. Don't forget that power being absorbed, which is on the first quarter of the current cycle, power is absorbed, which is positive, in the magnetic field of the coil, which is inductor, and then power being returned to the supply on the next quarter cycle, that the power is returned negative to the supply, and so on.